Good morning. Welcome to Spring. We are about to start, so please have a seat.
So if you're not looking for Spring, this is probably a good time to leave the room. If you are looking for Spring, we'll get started. This is the note well. It's Wednesday. I hope you've seen it already. If not, note it well. We will need both a Jabber scribe and a minute taker, and we're blocking on continuing until we have both. So do we have any volunteers for minutes? I'll try add some things, but another minute taker would be useful. Any volunteers? What about Jabber scribe? Thank you very much. Minutes. Folks, we have a fairly packed agenda, so if it's a volunteer for minutes would be super useful, please. Okay, I'm just going to assume that someone's going to help me with it. If not, we'll start blinking. There we go. Thank you very much, Cole. So last time and for the last few IETFs, we've been going through a recharter. We are now done with our recharter. Woohoo! You can see the charter. It's been discussed in fair length on the mailing list. So hopefully it's not a surprise to anybody. In general, we're going to give preference in meetings to drafts that address the charter items rather than those that are outside of the charter. I think there's not a huge amount that isn't included in the charter that we discussed working on. One note I think about the charter is that in general it requires a lot of collaboration across working groups. So it would be very useful to have a view if you have a draft elsewhere that needs some attention from Spring. Even if the work is progressed in another working group, please make sure to include the Spring alias just to cover anyone that's interested in the area. There was some discussion around the implementation requirements policy that we'll use per working group. Martin asked us to have a look at this. It was discussed in the plenary at IETF 102 and then by the IESG. The implementation policy is essentially what do we require in terms of implementations before progressing a document. It's defined on a working group by working group basis. There are a number of different sort of suggested implementation policies. Ranging from we need 2 interoperable implementations and detailed reports of them down to we don't care. We don't really have time on the agenda today. We were already significantly oversubscribed for the time, so we'll, after this meeting, initiate a thread on the mailing list. In general, we think Spring is kind of easy in this area because we don't really have a huge amount of things that we standardize ourselves. So the own working, like the ISIS working group or the IGP working groups can do their own, can choose their policy there, which probably affects it more. And so we're considering just taking the route of having known implementations documented in the implementation status section of documents from Spring. But we'll start a thread on the mailing list about this. There is another thing that we were asked to highlight, which is there has been, since May 2017, there has been an updated requirements, keywords document replacing 2119. The ISG still sees a bunch of documents that have 2119 in them rather than 8174. You should update it and use the boilerplate from 8174 rather than the boilerplate from 2119. Please do this if you are the editor or author of a draft in Spring. So, a bit of information on the agenda. Again, we had significantly more requests for time than we have time in the meeting. I think this time it was something like 200 minutes for our 2-hour slot. This means that we have to disappoint a bunch of people and say that they can't present at the meeting. Our preference is generally given to working group items if they have been through some update. We've got no working group items on the agenda today because really there was no update on those during the interim period between meetings. That's kind of disappointing, I think. I think we need to finish the docs that are working group items before we necessarily progress a lot of other things. And then we give preference to things that have been discussed on the list, which has been, again, relatively quiet. Please discuss your drafts on the list. It gives you more chance to get feedback from folks who aren't here. It gives more detailed feedback, especially given the time that we have here. And it will give you a better chance of getting a slot on the agenda when you are presenting things. We prefer, as we've said before, to use these meetings for time for discussing open items rather than giving overviews of new drafts. This time we've also tried to accommodate presentations that overflowed last time. I think last time Rakesh had 30 slides in about 30 seconds, so we tried to also re-include that this time. So this is our agenda for today. It's pretty packed. We have about 6 minutes of speaker shuffling, which I'm going to imagine that we'll use most of. The slots are pretty short. We've tried. I think we'll end up overflowing. Please focus your presentations on things that we need to address inside of the working group rather than the need and updates which can be gleaned from reading the document. So the documents that we have going, I kind of mentioned the progress on the working group items. We have a few documents that are with the RFC editor, which includes both the central EP and the LDP interop drafts. Both of these are currently blocked with missing references. The EP draft is on the IDR draft. The LDP interop is blocked on SRMPLS. SRMPLS itself, the authors are addressing comments. So Zafar has done some great job chasing the editors and helping drive that work. We're aiming to get those comments addressed pretty soon and get back to the AD on this. This document we really need to finish. I think there's a bunch of Spring work that really depends on this getting there, and it's implemented and has been stable for some time. It's really just a case of getting this document finished. The segment routing policy draft that we adopted that I think prior to the last meeting, I had raised some comments on the list. The authors have responded to some of them. I think would encourage some more working group review of this document. It's fairly substantial in terms of what it includes. The Yang model that for Spring, we had a review from Lada who as the Yang doctor, so thank you very much for that. And I think that it's those comments need to be addressed, and then we're probably ready to try and progress this after this meeting. We'll sync up with the authors on that. And then we have the MSDC draft. This has been undergoing a lot of discussion after IESG review, particularly on some wording around hashing and traffic placement of flowlets. The feedback I think would be that we've gone through here, and just as some insight into the discussion. There's a lot of detail here that's probably superfluous in this draft to Spring requirements, and has it's not necessarily specified in detail, but has implications in the transport area if you read it in certain ways. I think we should focus our drafts on things that need to be addressed in Spring rather than trying to overstep and cover every particular use case. So both the ADs and the ISG and Bruno and myself have had some input on this. So hopefully this will be, we can clear up this. It's been kind of 9 months addressing this particular comment. So we really need to close it and finish off with this draft. In terms of working group adoption, we have a couple of drafts, a couple of areas that I think we've had some discussion in a couple of meetings, and we have interesting competing drafts. So between the on BFD, we have these two drafts, that one for SR policy and one for more generally Spring BFD. We've asked the authors to consider merging, or at least ensure that these two drafts are consistent with each other. Ideally, we would issue a call for adoption of the resulting merged document when it's been done. That'd be based on agreement. We've already agreed this with MPLS and BFD chairs, that this work can be done in Spring. But yes, the ask here is to merge these two drafts because they cover very similar areas. We have two service chaining drafts, the service programming and the Spring NSH SR. We're proposing to start a wider discussion on what we need to standardize around service chaining on the list, and then use some time in Prague to discuss which of the documents that we have in this area the working group would like to progress. So I think Bruno and myself will kick off the discussion on the list, and then we'll reserve some discussion time in Prague for this. That will mean that there will be less time for presentations. So again, please only ask for a slot if you need one.
So regarding interaction and coordination with working group, so SRv6 is an extension to IPv6, and IPv6 is defined in 6-man. So we need to coordinate with 6-man. So as per our Spring Charter, we can't do protocol extension unless we have an agreement with the working group, protocol working group. So currently, for SRv6, the status is that SRH extension on the working group last call for a few months. The progression is good. Most of the issue has been addressed, but there are still a discussion on something like 6 or 8 issues. From my understanding, it's supposed to be resolved by December, and then 6-man will do another working group last call. Waiting for this, so 6-man shells would like to wait for this document, SRH extension, to be fully defined before we can consider SRv6 extension. So we'll not adopt any, neither Spring nor 6-man will adopt a document with SRv6 extension before SRH is fully specified. And then we'll see how it works. So there are a few options. One, as per the charter, Spring does the functional specification, and then 6-man the protocol work. Or we can do both in 6-man or both in Spring after agreement between shells. Zafar?
Yeah, I think the charter doesn't stop working group to work on items and take working group drafts without SRH, because it's going to be a huge dependency or backlog for any progression of SRv6 documents.
The charter allows us to work on functional extension, but for protocol extension, it needs to be done in protocol working group, or we can do it Spring with agreement with the chairs, which we don't have so far for 6-man.
Yeah, okay. So the struggle that I have is that there are documents, let's say my O&M document is one of those that would completely block if go this way. I mean, there's from a SRH where it stands, we have understanding of where things are, and the Spring Working Group can start defining. It's not a blocking factor. That's what I'm trying to say. There is a lot of work that has happened in SRH draft during the last times, and like since the last call as well. And there was a very good discussion yesterday where working group 6-man was agreeing on also major items are closed, and I don't think this, I mean, Spring should basically make it a blocking factor. That's my comment.
Okay, points taken. So far, we would expect some progression within 1 or 2 months, and then we will see.
Martin Vigouroux, Ali, that doesn't prevent you from working on your document. What Bruno and Rob are saying is that they won't be adopted until the SRH's situation is clear. But you can still continue working on your document. Okay? It's not saying stop working.
Yes, we can assume it's work items for the Spring document, for Spring Charter. So we'll allocate time as if it were a working document. You're also welcome to present it in 6-man, because it's possible that the document would be discussed in 6-man. So
Yeah.
you can work on that. You can advance the document. You can have slots in meeting on time to discuss.
Yeah, but I mean, we're aware that the implementation are happening, and then those implementation will be based on individual document, or individual document goes through a lot of private discussion and working group, not so much involved in working group. There's a lot of private discussion happens on individual document progression. So I think from a technology point of view, it is not a good thing. I mean, I don't see anything why we have a good base for SRH, why we cannot take more, I mean, start to close on the rest of the work, why we have to make it a blocking factor.
The discussion of an individual draft is entirely down to where authors want to discuss it, right? It's not to do with this is an individual draft, therefore it cannot be discussed on the Spring list. Please discuss individual drafts on the Spring list. I think this should already be gating for whether we adopt.
No, I mean, granted, but I mean, bear in mind there's a lot of implementations and they're happening based on individual draft. So at the end of the day, service provider will have issues. That's my opinion.
I respectfully disagree with your opinion.
Ali, again, SRH is being defined in 6 months. We don't decide how 6 months works and the pace at which 6 months works. Okay, you might have an opinion on the stability of SRH, but we rely on what 6 months decides for that.
So the conclusion is to work on SRH to close the issues and finish the last call.
So, starting with Rakesh.
Yes, you have your time.
Hi everyone, good morning. Happy Diwali to everyone celebrating Diwali today. I'm Rakesh Gandhi, presenting a couple of drafts on performance measurement for segment routing networks. So these drafts are for the probes-based performance measurement. We also have a couple of other drafts for the in situ where the data traffic carries the PM information. I think Zafar is presenting one later today. So the first draft is for the UDP part. I'm presenting on behalf of the authors and contributors listed here. So the agenda for this draft, look at the requirements and scope, the probe messages, a few TLVs that we are defining. SR policy has ECMP, so we discussed that, and the next steps. So the requirements is to the performance measurement, delay, and loss for the SR links and end-to-end P2P and P2MP SR policies. Applicable to both SR MPLS and SRv6 data plane. We want to avoid bootstrapping PM sessions. That's the spirit of SR. Also stateless on egress node. Again, spirit of SR, both one-way and two-way measurements. I want to handle the ECMP for SR policies. So basically, the scope is to use the RFC 6374 and 7876 and define the IPUDP path for the probe messages. So as mentioned, the IPUDP path is defined for the probe messages for SR links and the policies. And they are sent with the label stack or the seed list for SR MPLS and SRv6 policies. And the payload is basically RFC 6374. So not inventing a new performance measurement protocol here. So we are requesting two INA ports, one for the DM and one for LM. So for the probe response message, there is RFC 7876 that defines the UDP return path. So if you're doing one-way measurement, you can use information from there. For two-way, we can use the information from the receive probe query message for the IP and UDP port. So this draft does define return path TLV. This is for the two-way measurement, and this way we can avoid the state on the egress node. The TLV may contain the seed list or binding seed for SRMPLS or SRv6 data plane. It also defines a TLV to carry sequence number. Also defines a TLV for the block number for loss measurement, as mentioned in RFC 8321 for the alternate marking method. As we know, SR policy, there are ECMP between ingress or transit and egress nodes. So the UDP header does allow us to take advantage of the hashing function to go over the various ECMP paths. And these are the standard hashing. Draft doesn't define any new forwarding behavior. So next steps, welcome your comments and suggestions. Many implementations of the building blocks already exist. 6374 has been around for a while, and so is RFC 7876. And so we do request a working group adoption. And this draft was presented at IPPM working group session yesterday. Greg.
Yes, Greg Mirsky, ZT. Can you kindly rewind it to the beginning, and then we won't go slide by slide?
That's good. From
yeah,
here?
next. Yeah, and next. Here. Okay, so you say that no need to bootstrap PM session, negotiate UDP port, and then you mentioned that you request two UDP ports, well known. So using well-known UDP ports creates a DOS vector attack. And your draft doesn't have any security consideration how you how you address the possible DOS attack. Because, for example, if we take TWAMP protocol, it uses dynamic ports on purpose, so to hide and basically use dynamic port numbers, negotiate them. Over time, we learned that, for example, in TWAMP Lite, yes, there is advantage of using well-known destination port on the reflector. And we already have RFC for that and port being rededicated, 862. So my question to you is, why to reinvent the wheel when we have already TWAMP Lite, and now we have a working group document and IPPM, which will reasonably soon will go in the working group last call on a stamp, which has all the properties that you describe here?
Yeah, good question. So the RFC 6374 has been around and has been implemented and used for MPLS. So it's good to bring that into segment routing and make it for SRv6 as well as SRMPLS. So the main objective is to use the RFC 6374. It's well-written RFC by Stuart, who is there. Again, 7876 has been there as well. So the motivation is to continue to leverage those two implementations that's out there.
But 6374 works over SRMPLS with no questions. For SRv6, TWAMP Lite or stamp works without questions. So why we need to ask for two more ports allocated and create another alternative protocol?
So the segment routing network has both the SRMPLS and SRv6 data plane. So you're not going to run TWAMP on some nodes and 6374 on some nodes or some parts of the network. You just want to use the same mechanism, 6374 in your entire segment routing network, irrespective of what data plane that some nodes may have.
If somebody wants to run the same protocol, you can run STAMP on both networks, no problem.
6374 has been around, has been implemented, has been deployed. STAMP, I believe, is a new, it's a working group document. It's not an RFC yet. I have not seen an implementation for it yet. 6374 is shipping implementation deployed in network today.
Okay, STAMP is backward compatible with T1 polite mode, and T1 polite mode being, if we look at the numbers, T1 protocol is 5357. This is 6374. So, you know, if we just talk about seniority and time around, but I really don't see the reason. Let's go next of your return path.
This
Okay.
one?
Stuart Bryant, I want to pick up the port question because you go back when we wrote. Go back, please.
Back,
Yeah, when we wrote 78, 76, there were many iterations of that draft, and in the early iterations, we had defined ports, and we had huge pushback from the port allocation people, and the general sort of policy is, unless you absolutely have no way of having a well-known, of having a dynamic port, well, you really need to find a way of having a dynamic port. So I don't understand why you're asking for any static port allocations. A, I think you're going to find it very difficult, and B, you could almost certainly deal with dynamic ports for any of this.
It means that you had to add LSPP kind of negotiation to get support.
I would suggest a very, very early discussion with the UDP port allocators before you end up doing what we did when we wrote 78, 76 and re-engineering it to put the ports in. If you need extra ports, you could extend that to define them. So if you want them for your other OAM operations.
We can talk offline.
Yeah, Sam from Google. Because it's Spring Working Group, I'll keep it to Spring specific questions. First one, for the scope part, are you making sure that the Anycast traffic is part of this or not?
So we need to discuss that and add the relevant information.
Okay. The other one is for the round trip kind of thing you have. Are you going to do anything on the egress for the SR segment?
Maybe we can talk about it, what specifically.
Sure, I mean, like, I just want to make sure, like, in this case, because you're having entire path back to the source, right?
Yes.
What exactly you're going to do? Are you doing anything specifically on the egress of the segment, that node?
So because of the UDP port, packet will get punted on the egress node, and it will use the return path to send the reply back. So there is.
Right. So the only question is, like, how do you make sure it gets punted on the egress node? That's because you have the interlevel stacks.
Yeah. So there is a segment list there. So it just follows the same as the data traffic. So only thing extra here is that the UDP port, UDP header gets exposed. The U port looks at the UDP port and punts it locally.
Right. But in this case, it may not look at the UDP port because you have the subsequent labels. It just forwards back.
Oh, it's not on the label stack. This is a separate TLV on the RFC in the payload, in the RFC 6374.
Okay, so the packet actually goes to the only, you have the label header only
to the egress. Yes.
I
yes,
see.
Yeah.
Okay, thanks.
Yes. Very good that we're on this slide. I can point that there is already a proposal for return path TLV in Spring BFD draft. So I encourage you to look at, and let's keep it number of new entities to the minimum, because it's the same idea of controlling the return path in traffic engineered environment.
Yeah, we can make it similar, but you still need to get the INI allocation for the TLB type, but we can have the similar TLB content. Because
Okay.
it's 6374 TLV, right? So
Yeah.
you need to get the INA allocation. for it.
And yeah, and again, I want to stress that especially in a Service 6 environment, if you don't have integrity protection and security of your data, that's a very difficult start.
Yeah, we can definitely address that.
Okay, thank you. So can you
Thank you.
can you initiate email on the list to address the comments, and particularly the dynamic or static UDP port?
Yes, yeah.
Thank you.
Yeah, I'll talk to Stuart Brandt as well. So the second draft, again, this is for the probe as well. So presenting this draft on behalf of the authors and the contributors. This draft is for the SR MPLS data plane. So look at the requirements and scope, probe messages for the SR links and the P2P and P2MP policies. We are talking about delay and loss measurements. Again, probe response messages and how we compute the various PM metrics and flood them in the network in next steps. So delay and loss measurement for segment routing for links and policies. And flooding the TE metrics in the network. So this is again for the SR with MPLS data plane, probe messages. We do have another one for the in situ performance measurement draft. So again, using the RFC 6374 and 7876 existing RFCs, and this draft is informational. So as mentioned, as defined in RFC 6374, using GAL header, the probe messages are sent for SR links. And for the P2P and P2MP SR policies, a label stack is used with the GAL header. The GAL for delay measurement, DM probes, there is a gas value defined. The same is used for the SR links and SR policies. And similarly, a gas defined for LM and same value used for SR links and SR policies. So that there can be one-way or two-way measurement. So for one-way measurement, the RFC 7876 URO UDP written path TLV is used. And for the two-way measurement, the response is sent the same way as the query message. So there is a path segment ID draft, and it can be useful for the loss measurement for accounting traffic. So this way we can do the performance measurement for SR links, delay and loss, and then compute the extended metrics, TE metrics, so the minimum delay, maximum delay, and so on, and as well as the packet loss metrics. And there are RFCs there today for OSPF, ISIS, and BGPLS. It's a draft to flood those values in the network. So welcome your review, comments, and suggestions. As mentioned, the many implementations for 6374 and 7876 already exist. We did present this draft in IPPA working group yesterday, and we are requesting working group adoption.
So could you clarify, Mr. Stewart, could you clarify, are you going to do coloured packet techniques in this? Because the 6374 worked okay in MPLS TP because there was never any ECMP. But as soon as you have ECMP, you end up needing the piece of work that's almost complete in the MPLS working group and is being discussed in IPPM of coloured packet marking.
Yes.
So what's your approach to the packet marking going to be?
Yeah, so we do have, so in the previous draft, we did define a TLV that can be used for this draft as well. Is for the alternate marking and identify the color of the traffic counter for this one. But yeah, you do need to get the different incoming seats on the egress to do the coloring.
Right, so you're going to basically double the number of SIDs to make this work. That's
Yeah,
the plan?
yeah, similar concept as the synonymous label that, you know,
So it'll be the synonymous approach.
similar.
I presume.
Yeah.
Okay. So twice as many SIDs, twice as many well-known node SIDs.
On the egress, it can be local seed on the egress node. It's not a well-known because it has to be unique on the egress, that's all.
Has to be unique on the egress for every possible source, yes.
Yeah.
Okay, can we go to the opening statement of this presentation? Yeah, this one. Yeah, this one. So you say that in-band probe messages. Are there any other methods to do performance measurement rather than ensuring that your test probes are in band?
So if you're doing, someone reminded me yesterday, and we may have to add the text in the draft, is that the loss measurement, basically, all you're doing is collecting TX and RX counters, so it can be done out of band.
Right, but this is a passive performance measurement. When we are talking about active OEM, I don't know about any other method just to try to ensure that you are in band, because otherwise you are measuring something else.
Yes.
So you're saying that this method is in band, but you're what? Saying that other methods are not in band?
The scope of the draft is to the in-band, in the sense that we would put the label stack of the SR policy and send the probe messages. So if you're doing a delay measurement end-to-end for SR policy, it would be the same as the one experienced by the actual traffic.
Right, I agree. So basically that's for MPLS, one of the methods to ensure that active OEM is in phase sharing with the data, with the flow that's being monitored. And I believe that it's quite obvious, so it doesn't need a draft for that.
Robin from Huawei. I have the question, not for the draft itself, but this maybe, I want to know this because this is related with the MPRs. So I'm not sure this standardization for this work is being done Spring working group or belong to MPR's working group before chair. Rob? So
I think we need to have that discussion.
Okay.
Okay. Thank you very much.
Next is security.
Well, I want to thank the chairs for putting my draft up here, even though it's a individual and a 00 version, and for putting me early on. We're a few minutes behind schedule. So I also want to say this is my first presentation in Spring, so be nice. Okay, so this is about rings. Eric, stop laughing. So you know what rings are. They're a simple topology that offers resilience. And so the goal is to make this work well. For RSVPT and LDP is kind of a pain to do this, to make them work well on rings. The other thing is we want to make this completely self-defining as much as possible. So the goal was to have a lot of help from the IGP to build these LSPs. So basically the LSPs are built as counter-rotating pairs. So for those of you who know BLSR, it should sound familiar. And the goal is, again, also not to configure LSPs and not to have to do a lot of work, especially if you're going to use this on lots and lots of access strings. So the way this works is you create LSP pairs. So you have a clockwise pair and an anti-clockwise pair. In the simple case, you need, if you think of all the metrics being equal, you need one node SID to go in the short direction and two node SIDs to go in the long direction. So here you see an LSP from R1 to R4, and the clockwise LSP is just the node SID for R4. The anti-clockwise LSP, you put in a node SID sort of halfway there, and then you go the rest of the way, so the IGP doesn't defeat you. So from R2 to R4, again, you just put in one direction, you just say R4. In the other direction, you may pick the same point or a different point, but you want to go about halfway and then go the rest of the way. And the really exciting part comes for protection, where suppose I'm on the R1 to R4 LSP, and at R2 I realize that I can't go towards R4 in the clockwise direction anymore. I will jump onto the counterclockwise LSP or the anti-clockwise LSP to R4, which basically means swap the R4 node SID with the node SID that goes to R4 in the other direction. So that's the blue LSP that you see there. And so you're essentially, you go from a one label stack or to a two label stack. There are cases where you need three node SIDs. So this is, painfully constructed example for this, but Bruno assures me that's the most you would need. So using this approach, in one direction you need one node SID, in the other direction you might need up to three node SIDs. But I don't know, I didn't know at the time what the upper bound is, but I think it's three, right? What? That's okay? Okay, so
two additional, yes.
Two additional. That doesn't answer the question. If you start with two, it could be four. But I think three was probably the maximum, but I'll leave it to a graph theorist or Eric, whoever comes first. So an alternative approach is to use a flex algo type approach, not necessarily that mechanism for flex algo, where you have a single SID that says, I'm a clockwise SID, and you have another SID that says, I'm an anti-clockwise SID. And no matter what the metrics say, because part of the ring discovery says, this is clockwise, everyone on the ring agrees that this is clockwise, this is anti-clockwise. So if everyone puts down the forwarding in the right direction, then I just throw that SID on the stack and the packet is guaranteed to go to the right place in the right direction. Again, if I encounter a failure, I flip it to the SID that goes in the other direction, and then I'll end up at the egress without having to worry about the metrics working against me. Until the ring has defined what is clockwise and anti-clockwise, you should be dropping any packets you see with these SIDs on top. Once the definition is complete, then you can put in the forwarding path that says, go this way versus go the other way. So there is a question of how to allocate these SIDs. I was a private conversation with both Bruno and Shraddha convinced me that there's configuration involved in doing all this, which is not a great thing because we're trying to make the rings come up on their own. There might be sRGBs as well, because unless you want to use a common sRGB for everything, you might say, here's sRGB for rings, and here's sRGB for regular node SIDs. So this is definitely a problem that I would like to address and make it easier. So we need more detail in the draft, for sure. We need to bring this approach into the draft. We need to define how to manage in a better way sRGBs as well as node SIDs, or these clockwise, anti-clockwise SIDs. A few more words about how to install primary routes and protection routes, when to install them, when to remove them. For example, if the ring is being redefined. If a ring change is occurring, maybe you should, again, drop all packets until everyone is clear on what directions. And I'm done for now. We will post another version of the draft with a lot more details. I will confess that I wrote this draft in 2 hours. I hit the deadline. Comments now if we have time, I don't know, or comments on the list, please. Wonderful. Greg, you're not going to come up and make me go to the first slide again?
Thank you, Katie. Next. Yeah.
Okay, morning everyone. This is an update of the segment routing for enhanced VPN draft. Okay, a little brief review of the motivations. We know that VPN has been widely deployed to support multi-tenancy in the operator networks. Basically, it provides the separated tenant address spaces and also the separated routing and forwarding tables. While there are emerging services which have more demanding requirement on the SLA, for example, the more strict requirement on the bandwidth, latency, jitter. So basically, we need enhancement to the existing mechanism to meet these demanding requirements. So enhanced VPN actually aims to enable multiple tenants which have this demanding service requirement in a shared network. And we need to ensure the high performance with a reasonable cost and the scalability. And it is also considered as a solution for the network slicing in the 5G scenario. The framework has been defined in TIS, and we just presented yesterday in TIS working group. So for the enhanced VPN, actually, it requires more integration between the overlay VPN and the underlay network. So we think it could work with existing overlay VPN signalings, the layer 3 VPN, layer 2 VPN, eVPN, etc. For the enhancement, it is actually, the foundation is we need the enhancement in the forwarding plane because the guaranteed SLA comes from the guaranteed resource or deterministic scheduling in the forwarding plane. Currently, we have several candidate technologies like listed here. We will not go to the details. And for the control plane, it actually needs to take advantage of the forwarding plane enhancement. So to build the virtual networks with enhanced characteristics. And the role of the control plane is also to give a good abstraction of the different forwarding plane technologies. So that have a generic mechanism in the control plane. Also, the scalability is an important thing we need to consider in the design. So we can see whether segment routing can support the enhanced VPN requirement. We know that currently segment routing is mainly designed for the explicit routing. We use different seeds as topological or service instructions. Then we can see as shown in this diagram, different service flows, they can share the same seed or seed list in the packet forwarding. And how about the performance guarantee? In this current SR, it is based on the diffserv queues to provide a class-based traffic differentiation. This may be enough for many of the existing services, but we can see it does not provide the solution for the per tenant or per service traffic differentiation or treatment. So it may not meet the requirement of the demanding services in the future. So here we define some enhancement to the segment routing, which is to put it resource information associated with the segment routing seeds. This is based on the forwarding plane resource partitioning technologies. For example, we can allocate dedicated link resource for different virtual networks on each link. And then we use different seeds to identify the different set of resource allocated. We can have the multiple adjacency seed for one link, each represent a partition of the resource. We can also have multiple prefix seed for each node. Then based on this mechanism, we could build separated segment routing virtual networks with different set of seeds. As shown in this diagram, we can build 3 separated virtual networks, each with a group of seeds used. In this way, the traffic in different virtual networks will be steered to the isolated resource according to the seed used. Then the VPN service can map to either dedicated virtual network or shared virtual network according to the requirement. This gives overview of the control plane procedures. Basically, this rely on the hybrid mode of the control plane. We need the controller to compute the virtual network topology and the resource needed according to the service request received. Then we need a controller to instruct the nodes involved to allocate per segment resource and seed for the virtual network. Then in the nodes, the distributed control plane will be used to advertise or report the information about the resources allocated and seed associated with the resource. Then the nodes will need the distributed control plane to build the virtual network topology and the necessary forwarding entries for the service. This is in Spring, we just defined the procedure and the architecture. The protocol extensions will be done in the relevant working groups. Here we summarize the updates since the last presentation. In the recent 2 versions, we add more details about the mechanism in the draft, and we describe the procedure with an example diagram. Also, the control plane considerations are added in the recent versions. We also clarify that the applicability of this solution to both the SR-MPLS and SRv6. There are also many editorial changes to improve the readability. We have received many comments on this draft. Here, just list some of them and the answers to the questions. The first is what extension to segment routing is needed. We think the extension here is to use segment routing IDs to represent the different set of network resource on the network segments. And how to reserve resource in the network? We need, this is the question asked during last presentation. And here we'd like to clarify that we need the controller first to compute the resource needed. Then the controller also need to instruct the involved node in the network to reserve the resource in the data plane in order to guarantee the performance. There's also concerns about whether this will add the state to the segment routing networks. I think the answer is yes. We will add more state, but the states will be necessary if the purpose is to provide a guaranteed SRA with the segment routing technology. And how about the scalability compared to existing technologies? Because this mechanism is still complies to the segment routing paradigm, they will not introduce per pass state in the network, just the per segment states. So scalability will be better than the end-to-end TLSP mechanism. Okay, so for this draft, we would like to solicit more comments and feedbacks so that we could improve it in the next version. Maybe later we can ask for the adoption.
There is a related document in TES working group, I believe. Okay.
Stefan Goski from Orange. Can you go back to your resource partitioning slide? Maybe there's something I'm missing because I haven't read the draft, so sorry for that. How do you partition resources by just allocating new seeds?
You mean
because you're telling that on the same link, you are allocating multiple adjacency seeds, but this does not provide any resource partitioning.
Yeah.
So what's the mechanism behind?
Yeah, in the forwarding plane, we can have multiple technologies to do the resource partitioning.
So it's not exactly the same link. It may be, I don't know, a different Flexi channel or whatever.
Flexi can be one candidate.
Yeah, whatever. You can have a sub-interface, VLAN or whatever.
Yeah.
But it's not the same link. It's a different link. I think from a logical point of view.
You can say it's a a separate logical link, but we can also hide this link from the protocol, from the IGP protocol. So just we consider it's a
Similarly, as we are doing for likes today, as we are able to allocate different seed for each lag member.
yeah. I think it's similar to that.
Ketan Talaulikar, Cisco. How are so there is a virtual network which is defined, and there are this node and prefix seeds which are additional state which is created to map. What is this construct of this virtual network? And I mean, what's the way in which, let's say, here you have colors, blue, for example, or yellow. How are they associated or grouped together?
Yeah.
I mean, how do you know that part is not very clear?
Yeah. You mean how do you know which groups of the seed or resource belong to the same virtual network?
Yeah. So if you, I'm just saying, if you look at, if we have the flex algorithm proposal, there are different prefixes for different algorithm, and that's how you know that that these are the grouping or a topology or something. How do you achieve the same here?
Yeah, I think there can be several ways to do this. One approach is what we proposed in the RSR working group, is to use a multi-topology to associate all the link and the nodes seed together for a particular virtual network. Use a multi-topology ID. It's one approach. Yeah.
Okay. So I think it would help if you clarify that this mechanism is about partitioning networks with multi-topology. I think that clarity would help. That's one. The other thing is some scalability analysis of how many, if you're doing multi-topology routing, how many such partitioning can be done, and what's the proposal that would help.
Okay.
Thanks.
Hi, Lou Berger. I'm actually going to respond to both previous speakers' comments. Stefan, he talking about whether you're modeling the resources as links or not. It's really a question of modeling, and there's options here. You can represent it as a queue, because fundamentally that's actually what it's going to do with the hardware, is you're going to have some allocations of a logical, virtual, or however you implement your queuing, you're going to get different resources. And you can model it as links, you can model it as sub-interfaces, or you can model it as queues. And it's a discussion for the working group to decide, decide what kind of modeling you want. And there is going to be some implications on scaling. And that also goes to the speaker immediately before me, is you can model it as multi-topology, or you can model it just as different SIDs that are available on that interface. And then if you're using a controller-based model, your controller can understand that it maps to different topologies, and no one else has to know that. It's just different identifiers with different resources available. So there are different options. And the chair mentioned that there's a related draft in T's, and we would hope that type of trade-off actually is defined in here, not in T's, because it should be driven by the actual use cases that this group has versus what's possible in an architecture. Because from an architectural standpoint, you can go many different directions, and you got to choose. So multi-topology routing, that's great. That works, but it has certain scaling properties. A controller-based model, if that works, it removes a lot of state from the network and has some real advantages to it, but doesn't line up with the use cases that this group wants to do. So you have some choices.
Thank you.
Stefan, again, if you want to partition, for example, using queues, we have also other mechanisms that could be used to identify the flow, like the EXP or DSCP. So you can also use seeds, but we can also use what we are using today, which is the EXP bit, for example.
Okay.
Right, but that has certain scaling limitations. So if you want to go have more flows or more logical resource handles or queues, then it's good to have an independent identifier.
Yeah, and actually you can use seed and the EXP together.
Right, and so this is the same thing we had in MPLS. I forget the draft with the ELSP and LSP. You can do exactly the same thing.
So could you progress on what kind of modeling you have in mind on the scaling analysis related to this modeling and related to the use case you have in mind? How many slides do you need for your use case?
Yeah, I think we can work more on the modeling in the after this meeting. Yeah, and we can have discussions on the mailing list.
Excellent, thank you.
Having built this thing 5 years ago in another company, you really want to start looking into decoupling your non-connected labeled next hop at egress node to the service itself, because in current proposals, assume you are going to map next hop in your LTVPN to the remote loopback. You really need to figure out how to provide some degree of interaction between number of services and number of remote loopbacks in a way. Otherwise, it's going to kill you.
Yeah.
Seen this before.
Mapping, you mean, from the...
Yeah, you're mapping server to non-connected remote next hop, right?
Yeah, something
if
like
you
that.
do one-to-one, it's not going to scale because it's one next hop per service.
We can support a flexible mapping one-to-one or multiple to one.
You need to figure out how to do it properly.
Okay.
Next is Mac. Thank you, Chief.
Good morning. My name is Mark. I'm going to present this update to the path segment in MPLS-based segmenting. Segmenting network. So here's the motivation for this draft. So as we know, signal routing is designed to as a source routing technology, is that directly encoding forwarding instruction in packet header. That means the path state is only maintained at the ingress node. There's no path state maintained at the transmit and the egress node. So that means when the packet reaches the egress node, some or most of the labels has been popped off. So for the egress, there's no way to determine from which SR path or packet is come. But for some use cases, for example, the path performance measurement on real traffic, bidirectional path correlation, the path identification at egress is necessary. So this trap introduced the path segment that can be used to identify our SR paths in the context of the egress load. So here's the review of this path segment. So a path segment actually is for SR MPLS network. A path segment is a label that is assigned by the egress load of an SR path. It can uniquely identify the SR path at the egress load. And when path segment used, it must be inserted at the ingress node, and it must be immediately follows the last label of the SR path. The SR path here can be either a sub path or end-to-end path. So when the path segment must not be popped off until it reaches to the egress load. That means the PHP function must not be enabled. So here's the updates made to this version since we first present in IETF101. Since that, we had a new author, Rakesh Gandhi, and since then we received a lot of online and offline comments. And according to those comments, two major updates made to this version. The first one is to remove the two label option for path identification. At the very beginning, we proposed two options for path identification. And considering that the major use cases for this path segment is to, for example, to do the path, to do the performance measurement and bidirectional correlation. Most of this thing should be done in the egress node. So we think is suitable to use the one label solution, that the solution is assigned by the egress. And the second one is to add a new section to describe how to support nesting of path segment. This is according to Sasha's suggestion. The idea is to use the binding seed and together with path segment. With this, it can reduce the depth of the label stack, and also it can support both sub-path monitoring and end-to-end path monitoring. We can see that in the next slides. And also, we do quite a lot of editorial changes to this draft and to make it more readable. So here's this diagram shows the details how to use the path segment and the binding seed to support sub-path monitoring and end-to-end monitoring. You can see that in the figure, there's a path from A to D that spans multiple scenarios, multiple domains, the access, the aggregation, and core domain. This is a very typical scenario in mobile backhaul network. You can see that in order to reduce the label stack, the depth of label stack, you can split the end-to-end path into several subpaths. In this example, that path split into 3 subpaths. And for each subpath, it can be allocated to one path segment and one binding seed. You can see that at the ingress, only the details of the first set list of the first subpaths need to insert and followed by the binding seeds. And the end-to-end path segment follows the last binding seed. And with this way, we can see that the depth of the label stack can be reduced. At the same time, both subpath monitoring and end-to-end monitoring can be supported. So here's the steps. As always, we would like to solicit more review and comments on the draft, and then refine draft accordingly. And the draft is the foundation of several ongoing work. For example, the path segment-based performance measurement, bidirectional SR policy, PCIe extension for path segment. And also there's parallel work that is defined SRv6 path segment. And also currently Huawei is implementing the path segment-based performance measurement and the bidirectional SR paths according to the requirement from some customers. And also, as I know, there are other vendors also trying to starting to implement such functions. So we would like to ask working group adoption on the draft.
Greg Merskiziti. 2 comments. I see that you have parallel work on a SRv6 path segment. I think that it might be something to consider to have one document that addresses path segment for SRMPLS and SRv6, because I think that their issues that you need to address will be the same. So basically, you want to characterize their path between 2 endpoints. Second is that I'm not sure that removing their 2ID label to characterize specific path between 2 endpoints brings advantages. So subsegments might require more SIDs to define explicitly which path between 2 endpoints being taken. So we can discuss it offline.
Sam Aldrin from Google. I have to say this because whatever segment routing, right, intended to simplify the whole thing, this kind of work is actually bringing too much complexity into the mix. I really don't understand why we have to do this?
Yeah, as
The reason is you're adding now more labels. Actually, you lost me when you said there's going to be another label in the mix. If you really have to solve those kind of problems, then adding more labels is not the solution.
yeah,
I think by the time we actually add more SIDs or labels, there's actually no more, label space to actually, in a sense, we can push more labels into the stack.
as I said in first at the beginning of this presentation, the use cases for this path segment is about, for example, the path measurement, performance measurement on real traffic. So because you want to do path measurement on the egress, you need to know which packet belong to which path, and you can counting based on that counting. So with the current mechanism, you cannot do that. So
Sure, I know you cannot do that. That's why you're adding more. So what I'm saying is adding more labels will not solve the issue. The thing is, so who is actually encoding this label? Who is putting into the label stack?
The ingress putting the label in into the label stack, but it's allocated by the egress. You need a controller to have this to allocate the path segment.
So in the previous presentation, we had one more accounting label or something. Now this is one more label, right? So it's just piling up on that. Am I right?
If you want to solve the problem or satisfy requirement, you have to do this, right? Otherwise, there's no way to do this.
So if you have to get the performance data on the intermediate nodes, right? You will have to add one more. If I see the picture,
now the use case is only required to maintain the states on the egress, only on the egress. If you want to intermediate or transit load to support this, there's other way to do this. For example, the IOM solution, right?
Okay.
Ketan Taravlikar, Cisco. So I think we should review more closely the use cases and where this is really applicable or needed. One comment is, for example, for the delay measurement, I don't really see that this is necessary. We can discuss more offline. The other part was that the path segment, the draft says that it has to be allocated from the SRGB or the SRLB. I think, if where it is really needed, it could also be a local label. So I think it will help if you clarify.
Yeah, you can do either from SRGB or SRLB.
Why not just a dynamic local label? Just a dynamic local, a local label from a dynamic pool outside the SRHG.
It doesn't matter.
The draft says it must be from SRGB or SRLB. And my question is, it can be just any local label from the node, right? The egress node.
Yes, correct. Just interrupt. 2 points. One, you explicitly stating that it has to be bottom of stack label. So anytime I need to look up it, I need to traverse whole label stack, look up for the both bit set, and then it's very expensive operation. You won't be able to do this on any low-end platform. So doing entropy label work, we thought about this as well. The easiest way is to put it, the bottom at least it stays there, but then half of the devices in the past might not support it. So you really need to think where you keep it.
No, this path segment only target to the performance measurement at the egress or path bidirectional correlation. So when the packet reached the egress, the up layer label has already popped off. So that the path segment directly present to that egress. So you don't need necessary to scan the label stack to find the path segment.
I thought you were going to use it for counters and
counter on the egress to accounting to account at the egress.
Okay. Second, since you're asking for working group adoption,
can you keep it short and we'll cut the line between? No. Okay, for Ron, but after for you. No, Ron, you can go ahead.
So when you ask for working group adoption, I'll publish to the list. help button years ago doing exactly that. Ericsson owns it, so you might need to consider it. Okay.
Thank you, Jeff.
Ron Bonica, Juniper. If I understand you correctly, the purpose of the path segment is to reconstruct what the path looked like when it left the source before labels were popped. Given that in SRv6, you don't pop labels and you don't throw away anything from the segment routing header, what's the motivation for doing this in SRv6?
Okay, although this draft is not about SRv6 path segment, but for that draft, yes, I agree with you. At the egress, it can use the SRH to recover the path, right, to identify the path. But from the implement point of view, it's very difficult. It's not friendly to the hardware implementation to compare a very large or variable length field to compare with to determine the packet from which path. That's that's an optimization to that.
Okay. Second part of the question, the destination node can use the path segment to reconstruct the entire path as it was when it left the source. I assume any other node in the network can make the same transformation. It has access to the same IGP. Given that, what do you need the rest of the labels for? Every node could generate the whole label stack.
You mean the path segment for SRMPS or path segment for SRv6?
No, this is an SRMPLS. Every node could generate the whole label stack. I'm following up on Sam's comment. What you've essentially done is reinvented the label that RSVP used to use. Yeah, LDP, sorry.
So this is about segment routing.
Yeah.
Okay.
Robin, we closed the line.
Yeah, but for your point.
Can you send it on the list, please? Just to be fair with Stefan. Thank you. So next is Shradha.
Good morning, everyone. I'm Shraddha Agde. I'm presenting TTL procedures for SRTE paths on behalf of co-authors. To start with, let's see what is the use case we're talking about. So we have this network R1, R2, R3, R4, R5, and we have a SRTE path which is represented using two labels in the label stack, 1004, which is going to R4, and then from R4 to R5. So the label stack is 1004 on top and 1005 on top, at the bottom. So what we want to do here is to be able to trace this path to see where exactly the packets are going when we have this SRTE path constructed on the head end. So we are doing an MPLS traceroute procedure from the head end. So according to RFC 8287, we suggest that you have to have the tunnel that you're tracing. The TTL moves from 1 to 1, 2, and then 3, 4, and so on, and then the bottom labels are all set to 0. So let's start with the top label 1004, which has 1, and then the first step is like the top label has TTL 1 and the bottom label has a TTL of 0. And then on step 1, packet reaches from R1 to R2, the TTL expires, and so packet is punted to RE, and it generates an MPLS echo reply. And since R2 is transit for the label 1004, it sends that return code in MPLS echo reply, which says R2 is the transit. So when R1 receives an echo reply, it increments the TTL to 2 for the top label, and then in the step 2, it takes the packet. The TTL of the top label becomes 2, and then it sends the packet out. So in step 2, the packet reaches, it transits R2, it reaches R3, and the TTL expires on R3, and then packet gets punted to R3, and it generates an echo reply that it is a transit node. R3 is doing a PHP here. It's and it's short pipe mode with all PHP. So at R3, the label gets popped, and the bottom label gets exposed. So when R3 sends transit return code to R1, R1 further increments the TTL of the top label to 3, and then the MPLS trace route procedure, MPLS echo request message is sent again. So this time when the packet reaches R3, the TTL does not expire because it is 3, so you still have TTL left. So but then the packet, the top label gets popped, so bottom label gets exposed, and packet reaches R4 with bottom label 1005 with TTL of 0. So this could be problem because incoming TTL is 0, so packet may be dropped or rate limited. So even if we assume that packet is punted to R4 and then R4 generates an egress return code, the next step will again have a problem because now R4 generates that I am egress, and then so so we are done with tracing the top, the first tunnel, and so now we start tracing the next tunnel, which is 1005, and so we set the TTL to 1 for 1005, and then because R3 is popping the label, so when the label reaches R4, the TTL again expires. So our expectation in this step was to reach to R5, but the TTL expires on R4. So this was the problem in short pipe mode, where we don't copy the TTL from top label to the bottom label. So let's see how it works on uniform model, where we copy the TTL from top label to bottom label. Yes, correct. Do you have a question? Or
Yes, I'm sorry to interrupt, Greg Mirsky, ZT. We have OSP ping for segment routing, the RFC 8287, and section 7.5 specifically discusses TTL considerations for the trace route. Why do you think it's not sufficient?
So it's not very specific how to handle the PHP case, and that's what I'm trying to. It does not very clearly specify how do we handle PHP case, and that's exactly the problem that I'm describing.
So this document to update 8287, or because I'm not sure that there are a lot of
those are logistics, like whether we have a new draft or we update 8287, those are logistics, I guess.
It's in the draft.
Okay. Okay, thank you.
Luberger. Something I didn't get in the draft, in the problem statement, is what makes this SRTE versus just SR?
So this problem is very specific to the stacked labels. Everything just works fine if you have a single label that ends on R4. So it's, if you see the previous one, so the problem is for the bottom label. So R4, you're good, right?
Yeah, I guess part of my problem is there isn't a definition of SRTE, so I don't understand what it means.
A stack of labels.
I understand what a stack of labels are, but if it had said that, I would have understood it. But it didn't. It kept saying SRTE, and there is no definition of SRTE, and it gives a reference, and I get lost. So it'd be good to clarify that that's the problem, and maybe that would help Greg too.
So,
Okay. Let's go
you're
into
suggesting that we need a
policy.
definition for SRTE. Probably that's not going to be the objective for this draft.
Then remove the term and just say stacked labels.
Oh, okay.
Or SR policy. SR policy.
Sure. Let's move on to to describe what's the problem with uniform model. So uniform model is where you copy when the label is getting popped, you copy the TTL of the top label into the bottom label. So so the first step and second step pretty much same, no difference. So you set top label to top label TTL to 1, and it expires on R2. It sends transit. And then you increment the TTL on the ingress to 2 and then send the packet again. And then it expires on R3, and then it says R3 also says it's transit for label 1004. So at this point, the label is getting popped from R3 to from 1004 is getting popped at R3. So it is supposed to copy the TTL from top label to bottom label, but that doesn't really happen. So if you really see this step 3 where we've incremented the TTL of 1004 to 3, so it's even if it's getting popped, if we expect that it copies from top label to bottom label, that may not happen because so MPLS TTL copy mechanisms will not copy the TTL from top label to bottom label if the bottom label has a lower value compared to the top label. So that's done to avoid kind of in MPLS data packets, if you have TTL for the bottom tunnels set to 1, then you need to honor that. You cannot copy the TTL from the tunnels that you're traversing, which is outer tunnels. So we need a solution for this. So what's the solution? So we need, when we reach, in PHP case, when we reach the PHP node, we have to increment the bottom label TTL to 1 instead of waiting until we reach the egress. So that's the solution we need. So let's see if we do that, would everything work fine? So step 1 is same. So you would reach R2, TTL is 1, so it would expire, you send back transit. Step 2, you would increment the TTL of top label, you reach R3, and R3 would say, I am PHP, and then once it says I am PHP, R1 would increment, next step it would increment the TTL of the next label to 1 when PHP is reached. And so when at R3, when the label is popped, so you would get the label 1005 would be exposed on R4, which has a TTL 1, and now the next step R4 would look into the packet because TTL expires, and the next step R4 will say egress, and then you increment the TTL of the bottom label to 2. So you go sequentially from R4 to R5. So the recommendation here is to use DD map TLV, so which gets generated on every node and it encodes the next hop information to say it's and then use the DS flags to set the P bit. There's a new bit defined which says I am the penultimate hop router, and ingress would look at it and then increment the TTL of the next label. So these are some of the alternate approaches evaluated. PHP router itself saying I am egress, and second approach setting inner label to 1. Third approach is setting inner label to 255, and then fourth option setting inner label to 2 on reaching egress. So PHP router itself sending egress return code has problems because you're not tracing the tunnel unto the up until the egress, so you might miss some of the things that have you are supposed to validate on the egress. So that's not the right way to go. Or also, it would not detect these kind of errors where R2 has misprogrammed or R4 has programmed a swap operation instead of an egress operation. And also, it does not guarantee that the traffic is hitting R4 before it's going to R5. So those are the reasons for which this option was not considered for solution. And then setting inner labels to 1. So to begin with, if you set all the labels to 1, all the labels in the label stack to 1. So this works fine when the network is programmed correctly. So let's say everything is fine, R1, R2, R3, R4, R5, everything is programmed correctly. Then if you had set the inner label to 1 to begin with, instead of waiting until you reach egress, then things would just work fine. But let's take a case when there is R2 has misprogrammed and it has popped, it's going to pop the label. So in that case, it may not correctly detect this MPLS traceroute procedure may not correctly detect this if we set the inner TTL to 1, because in SR the labels are pretty much everybody understands the labels that are there in the stack. So 1005 R3 would understand 1005 as well. So which would not have been the case, most probably not have been the case in LDP or RSVP, but here SR R3 definitely understands 1005. So when it reaches, R2 has popped the label, top label is 1005, so it comes to R3 and then it looks at, it's a valid incoming label, 1005 is a valid incoming label. And also the FEC is 4444, which is transit for this case. R3 has programmed transit for 444, so we may not be able to correctly detect. And this traceroute procedure may repeat, like just keep incrementing, it goes to R3, it says transit and then increment and not reaching. So compared to this, we thought that sending IMPHP information from R3 is a more elegant solution. So the next one is setting inner labels to 255. So this does not really work, because if you have set the inner label to 255, when you reach R3 and the label is popped, the next step you want to reach R4 and then you want the label to get, the packet to go to R4, TTL to expire, which does not happen if it is set to 255. So the last option is when you reach egress on R4, if R4 says I am egress, then instead of setting the inner TTL to 1, set it to 2 directly. So this also works well when everything is programmed properly, but it has the same problem as setting the inner label to 1, because if there's something misprogrammed, then you might not detect it. You may not be able to properly detect that this misprogrammed router, and it might just keep repeating the procedure. So request feedback from the working group on the draft. Any questions?
Barak Milanox, may I have a question? On the problem statement, you referred to the uniform model, where you claim that the TTL won't get copied if it's bigger than the next label. Question whether it's a best practice or per RFC behavior?
I could not find this in any RFC, but
Me neither.
Yeah, I think it's a best practice, and people can comment if they.
So maybe this is something that might need to be fixed, right? Because once you fix that, you kind of
fix in the sense you're saying you should copy.
No, essentially, if implementers following the RFCs,
so
then there is no problem.
Yeah, no. So if you look at this method, right? So if you copy, then you have a problem here, because you see 254, and if it was a uniform model and you're going to copy 254 to the bottom label, you have a problem. So shouldn't
let's go back to the uniform problem that you mentioned. So here, if you copy, then you should be good, right?
Yeah, but for this case, generally, if you look at MPLS networks and how packets are forwarded, it's not a good practice.
So I'm just asking whether uniform is a problem, or you refer only for short pipe.
So what I'm suggesting here is the practice that I'm listing down in red line here is the best practice. It's probably not there in any RFC, but I think that's the way it should be. I'm not saying, you change that, because if you change that, things won't work, right? Because if you change that, let's say we change that, okay? We say, you have to copy, then this doesn't work. right? This doesn't work because the moment you copy 254 to the bottom label, you're gone. Your trace route won't work. So what I'm suggesting is keep this best practice. If it's not, I'm not fully sure if it features in any RFC or draft, the statement in the bottom. We probably need such a statement because and people, and my understanding is, and I'm talking to people, MPLS veterans, my understanding is they do believe that most implementations do honor this constraint, probably not there in any RFC. People, if they have opinion, can comment on this.
Thank you. Sam from Google. I'll keep it short because I don't want to repeat what I talked yesterday. The only thing where you may want to consider is, in this case, you send the echo request, then you're expecting, because in the trace route, of course, you send the DD map, but if you send just like a ping packet for the specific node or something, you won't be able to really know, because you may want to send DD map along with the ping request or the echo request, or you may not want to. So if you don't send the DD map along with that, you may not be able to.
So this problem is specific to trace route.
Sure, I understand. Yeah. What I'm saying is, instead of DD map, if you can encode it to return thing, that may be a better option, but we can always discuss.
Yeah, we can discuss. Actually, we thought about it, like introducing a new return code, but we were concerned about interoperability issues. See, one of these things, right, because this 8287 RFC has been there, people might have implemented, having this one bottom label one, or, this last approach. So we don't want, if people are getting it working somehow, it should just continue to work for them. So that's another.
Yeah, definitely it doesn't work. This problem is real for sure. Thanks for explaining in detail, but I definitely would love to see not associating the solution to the DD map alone. If you can actually separate it out, it will be better.
Yeah, sure.
Thanks.
Sure.
If you could stick to your 7 minutes. 7 maximum,
okay.
Thank you.
Okay. I can do this one quickly. So this is about, so basically we have this EPE use case where, we have this draft for central EPE, which defines these 3 different kinds of SIDs for doing egress peer engineering: node SID, adjacency SID, and peer set SID. So when we have, when there's a network built inter-AS using these SIDs, you probably want to validate the control plane, data plane validations for this network, which are and paths which are built using these SIDs. So the cross AS fault localization is useful, and in certain cases, the cross AS OEM packets may not be accepted if they are in different ownership. So we are trying to address both of them, and then we need the target FEC stack definitions in MPLS OEM protocol to identify these new kind of SIDs, which are EPE SIDs. So this draft basically defines what are these SIDs, what is the FEC definition for these SIDs in MPLS OEM. So we have this for peer node SID and peer adjacency SID. So it basically has local AS number, remote AS number. Basically, the definition of SIDs is included in the target FEC stack definition. So when the label comes in with this, the FEC stack, and it can verify whether it matches with the definition of this label. And go ahead, Safar. So we have this peer set SIDs. Peer set is represented by a set of links. So the FEC stack definition has a set of links which is represented using the same block where you have this all the link representations using the local AS number, remote AS number, and interface addresses, as well as router IDs.
So I have one comment here. In the peer node SID, you can have peer there are part on different ASs. They are not in the same AS. With this encoding, you cannot encode that case. So that's the problem with this encoding. I just want to highlight that.
Yeah, but you could express those links as, I mean, the same thing repeats, right? So you can.
No. But what do you mean? Same thing repeats.
So this set of. So basically, it's a set of links which you're supposed to load balance, and then the same definition. I mean, you have it repeats, right? So you are representing a set of links, and then if that's what is your you can verify that this label represents this set of links, and then you're good.
In that case, do you have to repeat the local AS again and again?
Yeah, the entire
and
set
local...
returns, right? The entire set repeats.
Anyway, but
Yeah.
I think the local information, the local AS information, because that's the node that is advertising.
Correct.
So it's not a different node.
Oh, okay.
It's
Okay,
the
I
receiver
get what you're saying. Yeah,
that are
I get
different
it.
node, but so you have.
So it's repeating again.
It's
not
repeating
very-
again and again. So
yeah, and not optimized. Yeah.
Yeah.
Sure. I get that.
And in the node said versus the agency said, there could be cases where the interface is not known, but node SID validation work. So not in all cases for the node SID, you need to mandate the interface address information, because that may not be known, may not be known to the sender. But anyway, we can.
Yeah, we can probably take that
Yeah,
offline.
and I think it's going back to my side of things, right? But I think the other thing is also that the ping will end in a different AS. So we need some consideration with that, because the reverse path may not be there at all. So these are kind of things that we were looking into, and incidentally we were working on the same thing in parallel. But one of the things that we were looking is when you land on egress, you may not have the return path at all, so anyway, I'll go over some of this.
Yeah. So yeah, we did think about that as well. But what I was thinking was this is mainly getting generated from like performance management system. If you see RFC 8403, it talks about a performance management system which generates these ping and traceroute packets. So you could have a situation where the PMS has a connectivity to all parts of the network, and then it's so its source IP would be that PMS, and that's reachable. That's where we started with. Yeah, but what you suggest is that's definitely a use case as well. So we have two different procedures for validation, because it's cross AS. So in certain cases, if it belongs to same operator, he may be willing to allow that cross validation. And in some cases, that cross validation, like if a packet reaches the other AS, he may not accept it. So we have two different modes of validation, and that can be controlled via config. So that's what I have. So this is basically an MPLS working group. So I'm reusing the same slides. So I suppose this is supposed to be done in MPLS. The work is supposed to be done in MPLS.
Yes, both drafts have been presented in MPLS, and we'll discuss with the chair. Yes.
Yeah, sure.
Zafar, one question. It's supposed to be you on the next slot. But your subject but we are very late on the agenda, so we won't be able to have all slots. So basically, you are eating your own times. So do you prefer to present the same subject basically, or do you prefer to?
I can skip the overlapping part altogether.
Okay.
Go very fast.
Okay, if you prefer. Thank you. But keep in mind that you're eating your own time. So
yes, I like to go maybe. So this is Zafar Ali. I'm presenting it on behalf of my co-authors. So we were looking at this, the problems that 8287 does not address, the SID types. So there are three. BGP prefix SID is not mentioned there. BGP EPE that Shweta just talked about is not mentioned there, and binding path SID is not mentioned there. So we try to address, and it happened to be that for EPE, we were looking at the same solution. So I'm going to skip this because the changes are minimal. I would like to also mention that we're talking with the Shweta and the co-authors on the other draft to see if we can collaborate or merge the draft. So, so that is a discussion in progress. I would skip these because in the question I already mentioned some of the use cases that we try to address. Now for the BGP prefix, we don't need a new FAQ, but we need a description that we can use. So I skipped that slide already. Then for the path binding SID, we did put in a FAQ, which would be the header address, color, and endpoint. And but the really question is that the path binding SID validation procedure. So we did define something that initially should set TTL to 1 for the path binding SID validation. And the procedure are there in the draft. I mean, in the interest of time, I just want to highlight some differences, and the same thing for the BGP EPE. If the return path doesn't exist, or the peering node is a non-MPLS router to which we cannot forward the packet, then we also are recommending that the TTL for the label could be set to 1, so it expires. So these were with the procedure. I think we can discuss more in the MPLS working group. I think.
Okay, thank you. Next is Jim. Thank you.
Well, it should be 3 minutes. So a quick update on this draft. Originally wrote this draft so all the kids could play nicely in the sandpit together. We put it in SFC originally. This is a 4th version of the draft because we think it actually belongs in Spring rather than SFC. Basic intention of the draft gives a couple of application scenarios where the network service header can work with segment routing together deployed, while maintaining the separation of the transport and the service planes, which was the original intention of the SFC architecture. So 2 scenarios. There's a picture I showed last time, so I won't bore you with that. This is the first scenario with just using NSH using SR as the transport. And then this is an integration of the 2 where basically NSH follows the segment routing stack. The encapsulation details are here. All of this is in the draft anyway, but basically the NSH follows the segment routing stack, and we would use something like draft IETF, MPLS SFC encapsulation to indicate that NSH follows the label stack. For SR, there's the details there, but basically we added some detail in the new version of the draft to indicate how you would indicate NSH follows the segment routing stack. So changes since 102, we changed the name because we think Spring is the right working group. We added more detail on the SFF to SF interaction and the layering between segment routing and NSH. We added more detail on the SRv6 encapsulation, which is basically indicating a UDP in the next header field. So we need a UDP port or indicating an IP protocol number for NSH. Both of those are requested in the document from IANA. Conclusions, same conclusions as last time. Basically, next steps, we wanted to look to request working group adoption into Spring, but I heard the chairs earlier, we're going to have a conversation on this in Prague, so that's fine. and we can make some decisions then, and then we'll continue to refine the technical details in the document. Any questions?
Yes, thank you, Jim. You define how to encapsulate NSH into SRv6. Two questions. Is there already an existing document to define how to encapsulate NSH into IPv6 or not?
No, there's not.
And do you expect it to be different?
No.
So maybe it would be better to address that point in SIGMAN because it's okay. Thank you.
Good point.
Okay. Thank you. Next is Zafar.
So the next was SBFD for SR policy, but chair has a slide, and that is partly covered to that direction that chair want us to take. So we're going to talk with Greg and the author of BFD draft for the SR policy. And okay, so here what I would like to discuss is the SRv6 O&M draft on behalf of the co-authors that we have. There is quite a bit of history of this draft. This draft has been around and is very stable, and implementations exist for this draft. So, but the main point that I'd like to discuss here is that when we presented this, so there was last call for the SRH draft, and one of the comments during the last call for the SRH draft was that the OBIT definition should either be defined fully in SRH draft, or the OBIT definition should be removed from the SRH draft. So at that time, I think we made a mistake in terms of removing from the SRH draft, but then later on, it turned out that there are many use cases of the OBIT that are now spread around different drafts. So that includes the PM and also O&M for the service programming in SRv6 network and in-band O&M. So based on this, and this O&M, so based on this, it makes more sense to have the OBIT definition getting back to the SRH draft. So that is something that I suggested with the SIGMAN chair yesterday, and would be follow up on SIGMAN meeting list. Other than that, there's only 8 changes to this draft since the last time I presented this. So in the interest of time, I'll remove the scope, but really this draft does not define any changes to any existing ICMP procedure. They work seamlessly for SRv6 network. The draft does not make any changes to the SRH processing or IPv6 data plane. And it does not make any changes to, so essentially the only difference, the only thing that we're asking for is some new code point for the ICMP v6 type numbers so that we can have some more specific error codes and during the O&M for the SRv6 set. That's the only thing, but that's not sufficient enough or big dependence on SIGMAN. So I think from that perspective, what we would like to see is that this draft proceed in Spring Working Group and get adopted into a Spring Working Group. I don't see, like, even from an SRI definition point of view, there is any blocking factors because the SRI definition point that we discussed earlier during this, this draft is not touching anything for SRv6. So with that, I'd like the chairs to consider that request.
One thing you will need to do is there are a boatload of authors on the front page of this document. So before, it would be good to see that addressed before we start that process.
Yeah, for sure. Yeah. That could be addressed, but I don't think there should be a blocking factor.
It's not specific. It's not specific to this draft, and it's coming again. It's not specific to this draft, and it's coming again and again. So it's better to do it before adoption. And another comment is regarding IANA section. You cannot do self-allocation of IANA code point, so they need to be defined, and then we can do early adoption with Martin, but you cannot just pick one, so they need to be removed.
Yeah, for sure. We can respin the draft with the author list, trim the author list, and we can also remove any code point with negativity in the draft, and we respin it.
Thank you.
Okay.
So thank you, Greg. Martin speaking. I haven't read the draft, sorry, but if it is not a first come first serve code point, please remove it very rapidly, because otherwise, if people read the draft, they can think that it's been allocated and they start implementing, and that's messy afterwards.
I fully understand and I fully agree.
Thank you. Greg Mirsky, CT. I will not ask to rewind it. Couple comments. It's very nice draft, and it's nice that you demonstrate that existing mechanics works with SRv6. The question I have is that what is real need for OBIT if you have ICMP port number? So you identify OEM in IP through their well-known port numbers. There is no apparent need to have OBIT in SRH to identify that your payload belongs to the certain protocol, and you can parse it accordingly. So why are you bringing back the OBIT?
So when a node is processing a segment and it needs to perform O&M operation, you're not going to go down all the way to ICMP to find out the payload, what is ICMP payload and what it contains, and it needs to be done. At that time, node should not even have to worry about whether, and it's not only the payload for the use cases of OBIT are not only ICMP. The payload could be a UDP payload could be some other constructed payload, and it could be for some sort of in-band O&M, some TLV containing the payload. So it is completely
well, I think
relevant to what we are saying.
You're mixing in many things in one. So if we're talking about this draft and doing a ping and trace route, so the trace route works through TTL expiration, and if node has TTL expired on it, then you apparently look at the payload. If node doesn't have TTL expiration on it, then OBIT is irrelevant because you're just forwarding this packet. So again, I don't really see apparent need for OBIT.
No, but I'm just saying that just because you can use trace route, which is just like maybe 1% of the O&M thing, without using OBIT doesn't mean that you don't need OBIT. There are so many other use cases that you
again,
need OBIT.
let's say in this document, I suggest you remove all the reference to OBIT because it's irrelevant to the document.
No. So there are two flavors of use cases that are discussed, even for trace route: overlay trace and the underlay trace. So hop by hop trace, where we work on TTL, but the overlay trace works on OBIT. There is segment by segment ping that works on OBIT. Okay, so please read the draft.
No, okay. If you're trying to do underlay trace route, then you put certain constraints on your transit nodes of your tunnel that they need to understand SRH. And
no,
I think
no, not at all. No, they don't. They don't. And it fully explained in the draft, crystal clear.
Yeah,
they do not need to understand. When a node receives a packet where TTL expiry happens, that TTL expiry responds in ICMP error message, time exceeded, and it copies the invoking packet as much as copy it can make. This has been like 20 years. Like, this is not something new, and that node does not have to read SRH. It's crystal clear. I mean, it's mentioned in the draft very clearly. It doesn't need to understand SRH. So otherwise, I mean, nothing will work with classic nodes. This is how the SRv6 works with classic.
Right. So that's exactly. So why OBIT? What OBIT does in ping and trace route?
OBIT allows you to do, in this draft, the OBIT allows you to do segment by segment ping. OBIT allows you to do overlay for SRv6 overlay trace route. Okay. And then OBIT has other use cases that I listed before, the performance management and so
you're defining OEM functionality in two places. You're using some flag and you're using effectively protocol type through UDP port number, and that creates ambiguity. I suggest you read the draft that I put before Montreal on OEM identify, which analyzes this complexity, and it creates more confusion rather than helps things. So in IP, OEM being identified through the UDP port number, and let's not create the second mechanism which only confuse that, because what will happen if you have OEM port number like UDP or performance measurement and OBIT is not set? It's confusion.
No, we can take off.
Let's take it to the list.
Yes, please.
Yeah.
To the list. Greg, can you start a thread on the OBIT? Can you start an email on the list to discuss the
yeah,
OBIT?
Sure.
Thank you.
And actually, I'm glad that it's been removed.
It's being removed from this draft, but it's going in the SRH draft. Proper definition. So it's not being removed.
And Greg, if you want it to be removed, you need to discuss the 6-man now. Okay. Yeah, okay. No, it's back in 6-man draft. Greg, it's back in 6-man draft. Okay, so thank you for your time. Sorry, Zafar, for your 2 slots. See you in Prague.